Okay, good morning. Mr. Lesham is here, and we're moving on to our next sequence, which is geometric sequence. Bless you. We've dealt with them not last year. We kind of took a break from them, but we have come across them, I think, maybe even grade 9, but definitely we worked with them in grade 10. But we're going to add something very, very different. We're going to add quite a big thing. We're going to actually learn about a new operation, if that makes sense to you. But I'll explain. So let's leave for the minute this whole idea of sequences. Let's just solve some algebra, okay? So where did I put my blue one? So if I've got x plus 3 equal 1, how do I solve that?
You take the 3 to that side.
Okay, but how do I take? Can I just move copy and paste? Or? So I'm minus. So if I have a plus here, that means I need to minus 3 on both sides. So I'm going to have x equal 1 minus 3, which is equal to minus 3, right? So whatever operation I have, this is called an operation, add. So I always do the opposite, minus. Okay? If I have 3x equal 1, so how do I get rid of that 3? Divide, because I've got a multiplication operator. The opposite, the reverse, the inverse of that is divide. So it's going to be x equal 1 divided by 3. Okay? If I have x divided by 3, how do I get rid of that 3? Time it. Okay? So the opposite of division is time. So x equals 3 times 1, which is 3. Okay, there's one more thing that I need to do, and that is, let's say I have x squared equal 9. Okay? How do I get rid of that square? I square root. So I'm going to square root both sides. Okay? And then I'm going to have x equal 3. So to solve algebraic equation, I always have to do the inverse operation, the reverse operation. Okay, now I'm going to stay with x. This is an x, like not an exponent. Yeah, it's a square. But what if I had, instead of x squared, let's say I have 2 to the power of x equal 9. So far, we've never come across that.
No.
So I want to get rid of the 2, right? But how do I get rid of the 2? I'll just pause here. Well, Ollie actually came up with a good idea. He said, which we actually did. If I could write 9 as a 2 to the power something, then I can do it. So for example, in grade, I think 9 or 10, we will give you a question like this. 2 to the power of x is 8. And then you can tell me, okay, but I know that 8 is 2 to the power of 3. And then I drop the base. But these kind of question, I can't write 9 as a 2 to the power of something. So I have to invent a new operation. Okay? And it's the inverse of the exponent. Okay? And that operation is called logarithm or log. Okay? Now, I won't lie, it's a little bit tricky, and you just gotta get used to it, okay? So, if 2 to the power x equal 9, that means that x is equal to log 9 base 2. I know, it does take a while to get used to, okay? But I will explain it again, right? It's just the definition, it's almost the definition of this logarithm. Is if you want to get the x, okay, you basically write x equal, and then you've got log 9, and the base, there's many different bases. In this case, it's 2. Now, the way to remember is that, you know, here we call this the base, right? We always call it in this exponent, that was the base, okay? And he's at the bottom. He remains at the bottom, okay? I'm going to write down the formula, the like general formula. Okay? And that's the one you probably should write.
So,
I'll answer question in a second. If I've got a, this is like the thing you need to write. If I have a to the power of x equal b, if that's the case, then a and b can be any number. That means that x will be equal to log. Maybe somebody can tell me what?
A and B.
So which one is at the bottom?
A.
A is at the bottom here, it will be at the bottom there. So log b base a. We're gonna have a lot of fun with these logarithms this year. Okay, let's pause. So just to finish this, you did put it in your calculator. Okay, this is not something you could do in your head. Okay, we got, what did we get? 2 to the comma? 3?
No, so 3 comma.
3 comma?
1 7.
1 7. I saw a different answer.
No, 1 6 9 9.
I got 1 7.
Yeah, no, you didn't write. So 3 1 6 9. So 3 comma 1 7. I think I need to show you. I'll just show you now how to do it in the calculator. Can I have a calculator?
Yes.
Okay, just in case, because I see you didn't get it right. So the way you write it, you're going to write log. Oh, hang on. Okay, I understand what the problem. So if you look here, okay, you've got a log, just log, but then you've got a log with a little square, a couple of squares. If you just use the log without any squares, that means you're using a base 10. Okay, so if you use your calculator, okay, and you didn't have specifying base, that's basically mean log base 10. If you use different bases, you'll get different answers. We must use the log base 2. So I gotta use this button, okay? So you write that, and then you get your log, okay, with a square, small square for the base, and the small square for the number. So then you go in and you put the base 2. I put a 3. Oops, you can delete. And then you go into the big square and you put a 9, and it should look like this. Okay, 3.1699. So yeah, 3.16. Okay, I'll pause and let's go back to geometric sequence. So we're parking this log business. We will use it in a bit. We're going back to geometric sequence. Okay, what is geometric sequence mean? 2, 6, 18. What will be the next term? That you think about. Correct. Okay. So Simon got it. Okay. What we're doing here, we're not adding. Okay. There's no difference. Okay. I mean, you can try. Let's say the difference here is plus 4. The difference here is plus 12. And then, and the difference here, what is the difference? Plus 36. 36. And then you think, oh, maybe it's quadratic. Let's see. Okay, so here the difference is plus 8. Here the difference is 24. So it's not quadratic. It's certainly not arithmetic. Okay. Simon was right. What we're doing here, we're timing by 3. Timing by 3. Timing by 3. Okay. Now we have learned about how to write down the nth term. That's what we're always interested in. Anyone remember how we did? We did way back in like grade 9, or maybe we touched on it 10, but we didn't do it last year. No. Oh, that's fine. So we get the first, we have to start with the first term, 2. And then we time it by the thing that we need to time it, which is 3. And then I have to power it by n minus 1. Okay? If you think about it, it's kind of, if I'm just going to write down the arithmetic sequence, well, hang on, I'm not going to do it just yet, okay? What I'm going to do now, I'm going to write the general term. What is generally it is, okay? For geometric sequence, you're always going to have, can I write here, yeah? A, I want to use the same later. A and R, I think, yeah. A, R, n minus 1, okay? That's your general term. But now we're just going to make sure we know what we mean when we say A, R, and N. What is the A?
First.
It's the first term. Okay. What is the R? What you multiply by. And that can be a number larger than 1, or it could be a number smaller than 1. Here the series goes up. If you multiply this thing by a third, it will get smaller. And we will look at sequences like that. So I don't know what to call it. The thing you multiply. The thingy you multiply.
Constant ratio.
The what? Sorry?
Constant ratio.
Constant ratio. Perfect. Much more scientific. And the n minus 1 is just the integer. I don't need to explain to you, right? N could be equal to 1, 2, 3, and so on, so on, and so on. Okay? Now I just want to write it, and I'll raise it straight away. to contrast this to the arithmetic sequence. Tn equal a plus n minus 1 d. Okay, that's what we looked at yesterday, right? A was still the first term, n minus 1, n minus 1. And here we have the difference, and here we have the ratio. So it's not too different, eh? Okay, let's pause. So we've done that stuff. I can't remember if it's grade 9 or 10, but we have done it. And then what I would ask you, calculate the value of the 8th term. What is the value of the 8th term? Easy peasy. How do I do that?
You replace n with
Correct. So I'm going to write the 2 times 3, 8 minus 1. Okay? In other words, 2 times 3 to the power 7. Now, here's the question I was going to ask you before and I forgot, but I'll ask you now. Can I write this as, well, 2 times 3, 6 to the power 7? Is that true what I've just done?
8.
No, it's definitely not true. Why is it not true? What did I violate here? Bod maths. Okay? Power comes before multiplication. So don't make that mistake. Okay? I definitely cannot do that. Okay, so then you just use a calculator and you get, I can ask these guys to give me the answer, 4,374. Okay? Question like that we've done. Not a problem. Okay? Hang on, there's a question. I'm just going to erase this, not to confuse you. I just wanted to show you that to compare it to arithmetics. Now, here's the extra bit that we do in grade 12. Now I'm going to ask you which term is the sequence is equal to 1, 4, 5, 8. So this is a term in the sequence. Maybe the 50th, maybe the, probably not. It's not going to be much. Which n is it? Okay, so what should I do? I've never asked you that question. You'll see in a second one.
Replace it with t.
Okay, so I'm going to replace that with t. So I'm going to write 1, 4, 5, 8 equal 2 times 3 to the power of n minus 1. Okay, well, that's something I should be able to do. Or maybe not. Let's see. What's the first step that I should do? Divide by 2. I can do it, okay? So help me out here. What is 1, 4, 5, 8? Do I have a... okay, 7 to 9. I'm just copying from it. You know, I'm actually going to write it here. Okay, so this is going to go there. So 7 to 9 equal 3 to the power n minus 1. Now, if I gave you this thing, even last lesson, you will be stuck because I want to know what n is, right? But the n is at the top. And until you learn about this log business, you wouldn't be able to find what else. You can't divide by 3 or what can you do? Unless, I know actually in this case you could, because we're always going to have, you see actually we didn't really have to have logarithms, yeah? Because this is going to be 3 to the power something. But it's going to be difficult to find out how it is. You're just going to do 3 times 3 times 3 times 3. Or you can use the fact. There's a little thingy here. But in other words, forget about I'm just rambling here. I just taught you logarithm. Let's just use the logarithm. It's much easier. Okay? This, I can use this rule to say that n minus 1 is equal to what? There's a log there, right? Because we want that thing at the top. What is the base of that log? 3. The 3 was the base here. It will stay a base here. And the number that I'm writing here?
7 to 9.
7 to 9. Okay? And you see it again, right? If this equals this power that means this is going to be the logarithm. The base stays at the bottom. 7 to 9. It's just getting used to this new thing. Okay? And what do we get? So what is n minus 1 equal to? 6. In other words, n equal 7. Now, there was another way we could have done it because we're only going to get answers which are integers. So I could have just wrote 7 to 9, and I think there's a little button that says fact, and then it would have told you that it's 3 to the power of 6. So you could have done it without logarithm, correct. But we will need these logarithms when we get to finance. I think term 2 we're going to go to finance, and then we will have to use logarithm. So it's a good idea to learn it now. Okay, I'll pause and see if you guys are happy with that. I'm going to do one more example, similar question, but now I deliberately went through this example because we have First of all, we have an issue. We have plus, minus, plus, and it's going to carry on plus, minus, and it's also going down. Okay, and I just pause for this guy to move. Okay, so what is the nth term? Okay, remember this is the equation we've got. Okay, first term times ratio and minus 1. Geometric sequence is actually pretty easy. So what should I do? What is the A? 4. Time, what is the R? Is what? It's definitely a minus there. It's definitely a minus. So we divide by 2. How? But I don't have a formula for divide. I need to multiply. So dividing by 2 is the same as multiplying by? Okay. We multiply by minus half. Okay. Half, because every time you can see you're multiplying it by half. The minus. Okay. Forget about the minus for a second. 12 times half is 6. Times half is 3. The next one, what will be the next one? 3 over 2, right? But because we have plus, minus, plus, the next one will be minus, we must multiply it by minus. Okay? And then minus times minus, we come back to half. So this is a signature of a negative R when you have plus, minus, plus, minus. Okay? Right, and then we're powering by minus 1. We don't have to think. It's always n minus 1. Okay? Now, are we happy with that? Now they ask you a question, what is the 6th term? I'm not going to bother doing it. You can just put 6. I'm not going to ask you. What I'm going to go straight away is, which term is the sequence is 3256. 3 over 256. So I want to know what n is. And what n will give you this thing. So as before, what do I do? Make it equal to 12 times minus half to the power minus 1. Okay? Just a second, I'll pause. Alright, so let's just carry on for now as just as we did before. So what will be the first step to do to solve this problem? I divide by 12. So it's going to be 3 divided by 12 times 256. Maybe we can simplify it straight away. I think I get 1 over 1024. Okay? 1 over 1024 equal to minus half to the power n minus 1. Okay? Just divide by 12. Alright. Now what was I told I need to do? I need to log it. Okay? I need to log it. So n minus 1 equal to what?
It is a new one. Oh, you just divided it. Oh, yes.
So you tell me. So the n minus 1, I found that one. Log to the power of what? So the base is negative half. Okay. Yes, that's what it seems to be. And then what's the number I need to put in? 1 over 1024, like this. Yeah? Now try put it in. Let's see what happens. So we have a problem. It says math error. The reason it says math error that actually we don't have negative bases. We don't have it. I can't really right now explain why that is the case. I probably and hopefully, but not 100% sure, will be able to explain that why you cannot have negative bases when we get to the financial, and then I'll come back to the logarithm and do a little bit more. But for now, you just got to remember you can't use negative bases. Okay? Yeah, it just doesn't like the negativity. Exactly. So then we got to think about where did that negative come from? Why did we have a negative half here? Well, it's because we have a negative half here, right?
Yeah.
But why do we have a negative half here? Because plus minus plus minus. Now, if you think about it, you know, let's say I'll write another sequence that is 12, 6, 3. Okay? So same sequence but without the plus and the minus. Okay? Now, in this case, what will be the base here? It's not going to be negative half, it's going to be half. But I'm going to get the same number, right? If I'm asking which one is this one, instead, it will be the same. So all I gotta do, and it's very cheeky, just get rid of that minus half.
No, so
Yeah, just allow it.
impossible.
So if you like have a negative base,
Yeah, yeah.
turn it to positive. It will work. And if you do it, and I want you to do it please, you should get 10. In other words, n minus 1 is 10, which means n equal 11. So as far as we're concerned, if you have a negative base, don't worry about it, just turn to positive. Okay? I'll just pause to see that you're happy with that. Okay guys, our last example of the day, and I've got enough time, but I'm not so sure of the battery, so I might pause this before the battery runs out. They tell me that I have a geometric sequence. They have to tell you. If they don't tell you it's a geometric sequence, then you can't solve it. Okay? So we've done things like that for quadratic and for arithmetic. Now we're doing with geosequence. And they ask us to find x. Okay, when we had arithmetic sequence, what did we do with these x's? What did we have to do? Minus that minus that. Then that minus that. We have to be careful and then make it equal, right? If it was quadratic, we minus then the differences as well. But this is a geometric sequence. So we're not minusing. What should we be doing? Divide. Okay? We got to divide. This is 7x minus 1 divided by 3x plus 1. It's actually maybe, I don't know if it's easier, but it's less messy, I think. That divide. Always the right divided by the left. And this is 3x plus 1 divided by x plus 2. So in this respect, I didn't have to it wasn't too messy. What do I have to do now? Make it equal. And this is an equation to solve. It's more difficult than the equation solved before. I'm going to pause the video now because it's getting a little bit too long and my battery I think is going to end. But I'll carry on with you. So, goodbye. Bye.